Dear students, I welcome you all for grade 12 physics lessons from today onwards. So, we will start from unit 1. Unit 1 about units and dimensions. But under this unit, today I am going to teach you competency level 1.2 and 1.3. So, let us see about competency level 1.2 and 1.3. You will learn about physical quantities and the units of physical quantities, and at the same time application of physical quantities. Under competency level 1.3, you will learn about dimensions and the method of using dimension for our scientific work. Dear children, the main purpose of physics is to discover laws concerning matter, energy and their interactions. Such information is very important to develop modern technology. So, in order to discover useful relationship among quantities, we need to measure them first. We need to measure them first. Therefore, the quantities that can be measured are called physical quantities. The quantities which can be measured is called physical quantities. In physics, we are going to learn about physical quantities. So, from today onwards, under this unit, we will talk about physical quantities. And at the same time, do you know the meaning of measurement? Do you know the meaning of measurement? Measurement means comparison with a certain standard of the same kind. Measurement means the comparison with a certain standard of same type. So, if you consider that, we can define a unit. We can define a unit. So, if I consider a standard unit for a certain physical quantity, we have to compare it with a same type of standard quantity. Consider the physical quantity length. What did you learn when you were in O-level class? The meter is the measurement of length. If you consider about time, yes, second is the measurement of time. So, like that, we have special units for different types of physical quantities. But if you consider long time ago, people use different types of units in different countries. They use CGS system, FPS system, but for our scientific work, we need a certain internationally recognized set of units. Therefore, in 1960, at 11th Geneva Conference, scientists have introduced 7 fundamental units called base units. They are independent from each other. So, now you can see the base units: length, mass, time, electric current, thermodynamic temperature, luminous intensity, amount of substance. These physical quantities are called fundamental units. And meter is the measurement of length, kilogram is the measurement of mass, seconds is the measurement of time, ampere is the measurement of electric current, Kelvin is the measurement of thermodynamic temperature, and candela is the measurement of luminous intensity. And at the same time, mole is the measurement of amount of substance. So, meter can be given by using this abbreviation simple m. To denote kilogram, we use simple kg. Seconds, simple s. For ampere, capital A. Kelvin, capital K. Candela, simple C and D. For moles, it is MOL. So, dear children, keep that in your mind. There are 7 base units which are independent from each other. Actually, they are the building blocks of our physics. So, if you come to these 7, other than these 7 fundamental units, there are 2 supplementary units to measure the angle. 2 supplementary units to measure the angle. So, to measure the plane angle 2D view, we use the unit radians, and the symbol is RAD. And solid angle, we use the unit steradian, and the abbreviation is SR. So, finally, other than 7 fundamental units, we have 2 supplementary units. Altogether, there are 9 units which are independent from each other. Now, can you remember when you were in O-level class, did you write the unit for physical quantity like this? What I have shown here? Yes? These things you must have written. In addition to this, you must have learned some other physical quantities also. When you are considering the units of velocity, you must have written it at meter per second. For acceleration, you must have learned it as meter per square seconds. But do you see them here? No. Then what are they? They are called derived physical quantities. They are called derived physical quantities. So, a physical quantity that can be defined by using fundamental quantities are called derived physical quantities. Right. Let me explain you about this. If I consider area, how do you define area? It's length into length. Length into length. This is the definition. So, length is measured in meters, and length is measured in meters. So, because of that, this can be written as square meters. So, units of area is square meters. If you consider velocity, how do you define velocity? Displacement divided by time. Displacement divided by time. Displacement is measured in its a length in meters. Time we measured in seconds. So, velocity as unit ms minus 1. So, these physical quantities are called derived physical quantities. Derived physical quantities. So, let me explain few. Area, what I have explained now. Volume, length into length into length. So this is how we write. The units of volume is cubic meters. And if you consider about velocity, units of velocity is ms minus 1. Acceleration, velocity divided by time. So you can consider it as meters per square second, meters per square second, or ms minus 2. So like this, you can define derived physical quantities by using fundamental units. Now if you look at the board, you can see force, mass into acceleration. You should know the definition to write the unit. Work, energy. Work means force into displacement. So unit of force is kg ms minus 2. And again, displacement is measured in meters. So finally, you can write the units of work as kilogram square meters per square second, kg m squared s minus 2. So like that, by using fundamental units, you can write units of derived physical quantities. Another one, density. The definition, mass divided by volume. Mass is measured in kilogram, volume in cubic meters. So finally, you can get the units as kg m minus 3. If you consider about frequency, how do you get? Number of rotations per second. So number divided by time. So numbers, they don't have units. So I will just write 1. Time is measured in seconds. So s minus 1. So electric charge, you can see them. So this is how we get units of derived physical quantities. Let me see about this. Force. How do you get the definition? Mass into acceleration. How do you write the SI unit? Mass is measured in kilogram. Acceleration is measured in meter per square second. Meter per square second. Once you simplify, you can get kg ms minus 2. So this is the SI unit, or fundamental unit of measuring force. Did you learn that when you were in grade 10 and 11 class? What did you learn? Your teachers must have told newtons is the measurement of force. The unit of force is newtons. That is what they must have told you. And at the same time, if you consider work and energy, this is the fundamental unit that we get, kg m squared s minus 2. Kg m squared s minus 2. But you must have learned it as joules. So, dear children, there are some derived physical quantities which have special names. So, some physical quantities have special names. This is the fundamental unit. This is the fundamental unit of derived physical quantities. But other than that, they have special units. So for the exam, you can write the special unit, and at the same time, you can write the fundamental unit. Did you understand this? Right. So now, let me explain this. The special unit for force is Newton. And work and energy, the special unit is joule. So abbreviation is capital J. Moment means Newton meters. Newton meters. Power is measured in watts, capital W, capital W. Pressure is measured by using pascals, capital P, simple A. And at the same time, electric charge we measure by using coulombs and capital C. Right? So, like that, there are some physical quantities which are very familiar to you, what you have learned when you are in grade 12, grade 10 and 11. What are they? Electric potential, electric capacitance, electric resistance, frequency, magnetic flux density. All these are derived physical quantities which have special names. So, now I have explained you 7 fundamental units, 2 supplementary units, and at the same time I have explained you derived physical quantities and their units. You know, children, some physical quantities do not have units. Some physical quantities do not have units. Why is that? When you define a certain physical quantity, if it is a ratio of same type of physical quantity, so they don't have units. If you define a certain physical quantity by using a ratio of the same physical quantity, then what will happen? They don't have units. As an example, I have taken here coefficient of friction. Coefficient of friction is the ratio between two forces, two types of forces. If you consider refractive index, it's a ratio of two sine angles. If you consider relative density, how do you define relative density? You have done when you were in the O-level class, right? What is it? Ratios of two densities. And efficiency, the ratio of two powers. So, because of that, these physical quantities, I have given you few examples, these physical quantities do not have units. So, keep that in your mind. Some physical quantities do not have units. Right. Okay. Next thing about the meaning of prefixes. Prefixes used with units. If you consider a certain physical quantity, as an example I will take length, right? The measurement of length can be a very tiny value, diameter of an atom. It's a very, very small value. And at the same time, if I ask you to measure the distance from Colombo to Kandy, that is a large value, right? So, length, I have taken the example length, it can be a small value and it can be a tiny value. So, we can say when measuring physical quantities, we have to deal with quantities which have spread over very wide range, very wide range. But you have to give the final answer with SI unit. You have to give the final answer by using SI units. So, to give the final answer using SI units, we use prefixes. Powers of 10, powers of 10, powers of 10. We can use positive powers of 10, and at the same time we can use negative powers of 10. Positive powers of 10 are called multipliers. 10 to the power 1, deca, the unit prefix we call is deca. Abbreviation is simple DA, simple D and A. If you consider 10 to the power positive 2, prefix is called hecta, and the abbreviation is simple H. If you consider about 10 to the power 3, prefix is kilo. The abbreviation we use is simple K, simple K. For 10 to the power 6, it's called mega. Prefix is called mega, and we use the abbreviation capital M. For 10 to the power 9, prefix is giga, the abbreviation is capital G. And 10 to the power 12, prefix we called tera, and that is capital T. So 10 to the power positive powers of tens, we give big values compared to the standard SI unit. And if you come to submultiples, they have minus powers of 10. So you can see a lot here: 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, minus 6, minus 10, 10 to the power minus 12, 10 to the power minus 15, 10 to the power minus 18. So these are the prefixes we use to indicate 10 to the power minus 1 is deci. 10 to the power minus 2, centi. 10 to the power minus 3, milli. 10 to the power minus 6, micro. Minus 9, nano. Minus 12, pico. 10 to the power minus 15, femto. 10 to the power minus 18, atto. And these are the abbreviations. In front of each and every prefix, I have given you abbreviation by using simple letters. And micro we write with mu, micro. So nano, simple N, pico with simple P, femto with simple F, and nano with simple A. So keep that in your mind. When writing numerical values, we have to use these prefixes. Let's see the guidelines we are supposed to use when writing prefixes. This is very, very important. So multiples of the basic units could be chosen in powers of multiple of 3. When you are writing, you have to consider multiples of 10 to the power 3. Kilometer, kilo 10 to the power 3 meter. Gigawatts, G 10 to the power 9. Megahertz, mega means 10 to the power 6. 10 to the power 3 here, 10 to the power 9 here, 10 to the power 6 there. So that is one thing. Next one, do not use compound prefixes. Compound means you can't write 2 prefixes at the same time. Millifarad. Milli means what? 10 to the power minus 3. Here you have to write 10 to the power minus 3 into 10 to the power minus 3. Instead of that, straight away you can write 10 to the power minus 6. 10 to the power minus 6 means microfarad. So you do not write compound prefixes when writing prefixes. And the other thing, do not keep a gap between symbols. When writing kilogram, millimeters, nanoseconds, here I have taken. Do not keep a gap between these symbols. That is how we write prefixes. Did you understand? Next thing, But when writing units of a physical quantity, keep a gap between symbols. When writing units of a certain physical quantity, you have to keep a gap between each and every abbreviation. That is what I have shown here. MS minus 1, there is a gap between meters and seconds. kg ms minus 2, there is a gap between kilograms, meters and seconds. So these are the things sometimes you forget when writing units. So when writing prefixes, do not keep a gap between symbols, but when writing units, you have to keep a gap between each and every symbol. Right? Okay. Right. Now let me explain how we use the prefixes when writing a certain physical quantity with their magnitudes. Write the following numerical values in SI unit. So first one, I have given 15 gigawatts. Giga means 10 to the power 9. So you can straight away write 15 instead of G, 10 to the power 9 watts. So this is the final answer. So you have written the value in SI units, standard units. You can get marks. You can get marks. Consider about this, 100 centimeters, 100 centi means 10 to the power minus 2, 10 to the power minus 2. So when you simplify 10 to the power positive 2 with 10 to the power minus 2, the answer is 1 meter. Right. Now let me see, 25 picofarad. 25. Pico means 10 to the power minus 12. Farad. 25 into 10 to the power minus 12. When you write by using SI unit. Now this is a special one I have explained here, 800 angstrom. Keep that in your mind. Other than prefixes, there are some units we use in physics. Angstrom, I will explain you. That is 1 angstrom. 1 angstrom is equal to 10 to the power minus 10 meters. Other than prefixes, we use this kind of things also. That is why I have selected this for you. So how do you write the answer? How do you write the answer? Yes, 8,000 angstrom means 10 to the power minus 10 meters. 10 to the power minus 10 meters. And at the same time, if you consider this, 30 liters, liters. What is the connection between that? Yes, 1 liter is equal to 10 to the power minus 3 cubic meters. Liters is volume, a unit of measuring volume. But you can't write in liters, right? You can't write in liters. You have to write the final answer by using SI units, cubic meters. Then how do you write 30 liters? 30 into 10 to the power minus 3 cubic meters. Cubic meters. So dear children, keep that in your mind. When writing units, you can use prefixes and you can save your time. You can save your time. So this is how we use units and at the same time prefixes to work out simple problems in our day-to-day life. Right. The next thing that I want to explain is about dimensions. Dimensions. Do you know the meaning of dimensions? What are they? Do you know? Right? Now, let me take one example. I am going to tell you something like this. Physical quantity is 16. What? Physical quantity is 16. Is there any meaning of telling that? No, there is no meaning. But if I tell you the physical quantity is 16 square meters, it will give you a meaning. You know the magnitude of the physical quantity, and at the same time you know the nature of the physical quantity. You know the magnitude of the physical quantity, and at the same time you know the nature of the physical quantity involved. Nature of the physical quantity involved. So, if you are not worried about the magnitude of the physical quantity, if you consider only about the nature, what? If you are not worried about the magnitude of the physical quantity, but if you concern only about the nature of the physical quantity, the basic quantities we can write by using different symbols. The basic physical quantities we can write by using different symbols. Length we can write by considering L. Mass measurement we can give by capital M. Time can be given by using T. So, these are called dimensions of a physical quantity. Dimensions of physical quantity. Now, you can see that I have written them in a parenthesis, but it is not very important to write inside a parenthesis, but keep that in your mind. Normally, we write inside a parenthesis, right? So, for your syllabus, we are going to introduce you only 3 dimensions: length, mass, and time. Keep that in your mind. Theoretically, when writing dimensions, you are not going to write numerical values. Numerical values. Actually, why do you want to learn about these dimensions? Why do you want to learn about these dimensions? At the beginning of this lesson, can you remember what I told you? Right? Can you remember what I told you? Yes, the main purpose of physics is to what? Main purpose of physics is to get the relationships, and we have to discover laws concerning matter, energy, and their interactions. That is what I have explained. So, we use dimensions for that. By using dimensions, we can find the units of a given physical quantity. We can check the correctness of an equation, and at the same time deriving a form of an equation. These are new things. You can derive a new equation by using dimensions, right? So, today I plan to teach you how to use dimensions for our scientific work. Let's see the first one, finding units of given quantity. Now, we will see how to write dimensions of a certain physical quantity. If it is area, area means we define length into length. length into length. So, dimensions of length is L dot, dimensions of length is L. So, that means L into L means L squared, L squared. So, that is how you write dimensions. So, first of all you should know the definition of each and every derived physical quantities. Now, if you come to the velocity, velocity means what? Displacement divided by time. Displacement divided by time. Displacement is a length. Time we write with capital T. Once you simplify this, you get LT minus 1. So, like that we can get, so dimensions of force. How do you get force? Force is, we can define mass into acceleration, mass into acceleration. So, dimensions of mass is m, dimensions of acceleration is L t minus 2. So, once you simplify you get MLT minus 2, MLT minus 2. The most important thing, you have to keep that in your mind, you can get the product of dimensions and you can divide dimensions, but you never add or subtract dimensions. You never add or subtract dimensions. So, now there are rules you have to consider. You do not write constants or numerical values when writing dimensions, and at the same time you cannot add or subtract dimensions, and at the same time you can get the product and you can divide dimensions. So, now we will consider the physical quantity energy. How do you define energy? Yes, amount of work done, amount of work done. That means you can have the same dimensions for energy also, m L t minus 2, m L work we can get what? Amount of work done, amount of work done. So, amount of work done means force into perpendicular displacement, perpendicular displacement. So, the dimensions of force is MLT minus 2, and if you get the product with dimensions of distance, so dimensions of displacement you can have ML squared T minus 2, ML squared T minus 2. So, work and energy, they have same dimensions, same dimensions. So, if you consider moment, pressure, density, frequency, you can define the way I have defined them, and without using units you can use the dimensions that I have given for respective quantities, and you can work out like this. I hope you understood about writing dimensions for a certain physical quantity. And next thing, I told you there are lot of uses. We will move to the second use now. Testing the correctness of an equation. What do you mean by that? If we have given you or introduce you certain equations in physics, they should have left hand side and the right hand side. If the equation is correct, if the equation is correct, it has correct dimensions, same dimensions in the left hand side and right hand side. So, dimension of left hand side of equation should be equal to the right hand side if the equation is dimensionally correct. If the equation is correct, That is how you write. So, I will give you one example for this. Consider the standard equation what you have learned in when you were in the grade 11 class. V equals u plus at. V or u we can give velocity, t is time, and a is acceleration. So, we are going to consider left hand side of the equation, velocity. So, dimensions of left hand side is Lt minus 1. And if you consider the dimensions of right hand side, you can write V plus At. V is a velocity, Lt minus 1, plus A acceleration. Dimensions of acceleration is Lt minus 2, and t is time, dimension is t. So, once you simplify here Lt minus 1, here Lt minus 2 dot t, that means there is a product, positive t, positive 1, and negative 2, negative 2. Once you simplify, you will get Lt minus 1 here. Lt minus 1, Lt minus 1. But I told you dimensions cannot be added or subtracted. So, if you add length to a length, it is a length. If you add velocity to a velocity, it is a velocity. So, therefore, Lt minus 1 plus Lt minus 1 means Lt minus 1. You can't add, you get the same physical quantity. So, dimensions of left hand side is equal to dimensions of right hand side. So, we can consider that the equation is dimensionally correct. That is how we check the correctness of an equation, correctness of an equation. Right. We will consider another equation. This is also a standard equation what we have taught you. S equals ut plus half at squared. Each and every term has standard meaning, but S is displacement. U is the initial velocity, t is time, once again A is acceleration. So, if you consider dimensions of left hand side, displacement is a length, so you can write it as L. If you consider dimensions of right hand side, ut plus half at squared. U is velocity, dimensions of velocity is Lt minus 1, time is t, positive. How about half? We never write constants when we write dimensions, so forget about it. What about acceleration? Dimensions of acceleration is Lt minus 2, and you have t squared. Time, the dimensions of time is capital T. So, once you simplify this minus t, positive t, simplify, and you will get the value L here. And here you will get the value L. L plus L is also L. L plus L is also L. So, dimensions of left hand side is equal to dimensions of right hand side. So, therefore, we can consider that the equation is dimensionally correct. So, that is how we use dimensions to check the correctness of an equation. So, these type of questions are in the A-level papers. So, you have to be very careful and must learn. Next one, we will do this one. If the equation is dimensionally correct, find x and y. Find x and y. If the equation is dimensionally correct, find x and y. Right. Now, in this question, it has given that the equation is dimensionally correct. You do not have to prove it because the equation is dimensionally correct. So, if the equation is dimensionally correct, each and every term has same dimensions. Each and every term has same dimensions. That means S equals xt. You can write like this. because each and every term has same dimensions. So, S is displacement, it is dimensions of S is L. If you consider x, we are going to find t time, dimensions of time is t. So, once you simplify, L divided by t equals x. So, what is L t minus 1 is x. So, x is dimensions of x is L t minus 1, x is velocity. So, what is x? X is velocity. Right. So, we will go to the next part. We will see if the equation is dimensionally correct, you can write S equals yt squared, yt squared. Why? Each and every term has same dimensions. You use that knowledge here. S is L, displacement. Y, we are going to find t is t squared. Once you simplify, y is L t minus 2. L t minus 2? What is L t minus 2? It is dimensions of acceleration. So, y is acceleration here, acceleration in this equation. So, these type of questions are there for MCQs. I will explain you the method of using dimensions to derive a mathematical equation. Mathematical equation. Look at this. Periodic time of a simple pendulum depends on the length L and the length L of the pendulum and the gravitational acceleration g. Derive an equation for the periodic time. Proportional constant is 2 pi. This is the question I have given. So, now you are going to derive an equation for periodic time. Derive an equation for periodic time. So, at that time, you have to consider what they have given in the question. Periodic time capital T of a simple pendulum depends on the length L of the pendulum and the gravitational acceleration. So, this what they have given, we can write with a mathematical equation. Periodic time T depends on the length of the simple pendulum L and the gravitational acceleration g. You can write this like this. Periodic time T depends on length of the pendulum and gravitational acceleration g. That is what you get from the question what they have given. So, now basically you have learned T is proportional to simple L g. But we want to write this with a certain mathematical form. So, we write it as T equals a certain constant Lx gy, Lx and gy. You have to write the indices when writing this. So, T is periodic time, L is length, g is gravitational acceleration. So, now we are going to use dimensions to find x and y indices. So, for that you have to write dimensions for each and every physical quantity. T is time. So, dimensions of time is t. If you consider length, here dimensions of L is, because it is length L. If you consider g, it is the acceleration. You can write it L t minus 2 and the indices y. So, this is how. So, you never write constants when writing dimensional equation. L is length, g is acceleration, these dimensions of acceleration. So, we can equate the indices of left hand side and right hand side. When equating indices, if you consider this is 1, we have to use this by considering simple values. So, here you can see x, here L, there is L, the power is y, you can write like this. And if you consider about t, that you can write it as minus 2y. You can separate the physical dimensions to simplify easily. So, now you can equate indices, left hand side to the right hand side. So, I will consider here one is equal to, the base is t, power is 1. Here base is t, power is 2y. So, you can write minus 2y. Therefore, you can consider minus half is equal to y. If you consider L, there is no length measurement there. So, we can write 0. 0 equals what? For length, this side is x plus y. So, from this equation we can write x equals minus y, x equals minus y. Already you have found out y. Therefore, you can write x equals positive half, x equals positive half. So, finally, we have found out x and y, and you can substitute these values to the standard equation what you have learned. So, here for this one, if you substitute k L half, power is half, g minus half, g minus half. So, in the question they have given the constant k is 2 pi. Therefore, final answer for periodic time t, we can write 2 pi root L divided by g. This is how we derive a physical equation by using dimensions. Right. So, you can do these type of questions and practice working out these type of problems. Consider about 2 or 3 questions given in the A-level papers. 2012 A-level question, if you go through, which of the following does not represent fundamental units in SI system? Yes, which of the following does not represent a fundamental unit in the SI system? Yes, 2012 A-level question. Meters is the fundamental unit. Kilograms is the fundamental unit. Second is a fundamental unit. Kelvin is a fundamental unit. So, Newton is a special unit. So, it is not included in a fundamental unit system. So, the answer is 2. Second one, if you consider the dimensions of power, you have to define power first of all. How do you write the equation for power? It is power is work divided by time. Work divided by time. I will write with simple letters. Work means what? Force into displacement divided by time. If you know the dimensions of force, what is it? Dimensions of force, m, l, t minus 2. S is displacement, you can write it as L. Time, dimensions of time is t. So, once you simplify this, it is m L squared t minus 3, m L squared t minus 3. This is the dimensions of power. This is how you use dimensions to work out problems in the A-level paper. Okay, dear children, today you have learned how to write units for a physical quantity, and at the same time you learn how to write dimensions for a certain physical quantity, and we got a chance to work out few problems. So, once again I will explain you problems related to units and dimensions for us when we meet again. Thank you very much for joining.